Three ancient wonders stand on opposite sides of the world, built by cultures separated by vast oceans. The Great Pyramid of Egypt, the stepped temples of the Maya, and the massive mounds of China all share a mysterious architectural blueprint. By the end of this investigation, you will see a hidden pattern connecting these monuments that challenges our entire understanding of ancient history. How did civilizations with no known contact design structures with such precise and identical features? What does this tell us about the origins of human knowledge itself? What single idea could possibly link these giants of stone and earth across continents and millennia? Sun-baked blocks of Egyptian limestone rise from the desert, a geometric mountain reaching for the heavens. Far across the world, the Maya built their own stone mountains, piercing the green canopy of the Guatemalan jungle. And in the plains of China, enormous earthen mounds, weathered by millennia, still dominate the horizon. These are not isolated wonders. They are part of a global architectural echo, a persistent theme played out in stone and earth by cultures separated by vast oceans and thousands of years. The pyramid form emerged independently, a seemingly universal impulse in human civilization. Each culture used what it had. The Egyptians quarried limestone, the Maya shaped local sandstone, and the Chinese moved colossal amounts of packed earth. Yet they all arrived at the same profound geometric conclusion, a four-sided structure pointing skyward. Even more compelling than their shape is their shared purpose. These were not merely tombs or temples, they were sacred instruments. Each was precisely aligned with celestial bodies, acting as a colossal calendar marking solstices and equinoxes. They served as centers of power, ritual, and cosmic connection, anchoring their people's place in the universe. This parallel development is one of history's greatest puzzles. Did the human mind, when reaching a certain level of social and spiritual complexity, naturally conceive of the pyramid as the ultimate bridge between earth and sky? Or does the repetition of this specific form hint at a deeper, shared source of knowledge, a forgotten blueprint whispered across continents? The closer we look, the more the evidence suggests this was far more than a simple coincidence. The foundation of every great pyramid begins with a square, a perfect geometric shape anchored to the earth. But this was no ordinary square. Ancient builders laid out their colossal monuments with their sides facing almost exactly north, south, east, and west. This precise orientation is our first and most profound architectural parallel. At Giza, the Great Pyramid's base is aligned to true north with a deviation of just a fraction of a single degree, a feat that seems to border on the impossible for its time. Thousands of miles away, the Pyramid of the Sun at Teotihuacan in Mexico mirrors this achievement, its massive platform squared perfectly with the cardinal directions. Even the great earthen pyramids of China, their original forms hidden beneath soil and trees, reveal the same underlying pattern of careful celestial alignment when examined by modern surveys. How could cultures separated by oceans and centuries achieve such identical directional precision? The answer lies not in the earth but in the sky. These builders were master astronomers. They determined true north not with magnetic compasses, but by patiently tracking the cycles of the stars, pinpointing the celestial pole around which the heavens slowly turn. The square base itself was far more than a stable foundation. It was a cosmic symbol, a representation of the world itself, with its four sides connecting to the four directions, the four winds, the four seasons. This concept of a squared Earth is a universal thread in ancient cosmology. from the Egyptian view of the world as a flat plinth to the Chinese belief in a square earth under a round heaven. The mathematical perfection of these bases is equally stunning. The near-perfect right angles and almost identical side lengths imply the use of advanced surveying techniques, perhaps involving ropes, stakes, and geometric principles like the 3-4-5 triangle to create perfect squares on a monumental scale. This shared blueprint of a directionally perfect square base is the first solid piece of evidence in our puzzle, a cornerstone of knowledge that appears again and again, pointing us toward a deeper mystery. Rising from that perfect square base, a second architectural marvel takes shape, the stepped layer. From the sands of Saqqara to the jungles of Yucatan, the pyramid did not begin as a smooth-sided mountain. Its earliest form was a staircase to the sky. The stepped pyramid of Giza in Egypt, the very first of its kind, is a stack of 6 massive tiers. The Pyramid of the Sun at Teotihuacan is fundamentally a series of stacked platforms. Even the ancient Chinese pyramids, now softened by time, reveal through ground-penetrating radar and excavation that they were built with distinct, sloping tiers. This was not a random choice. The step design was a brilliant and practical solution to an immense engineering challenge. How do you build something incredibly tall without it collapsing under its own weight? By building in layers, each level provided a stable, flat working surface for the next. Workers could haul materials up ramps built against the steps, achieving great height gradually and safely. It was a method born from necessity, a universal logic of physics and stability, but the meaning of these steps went far beyond engineering. In every culture, they represented a profound spiritual idea, the concept of ascension. For the Egyptians, the steps were a literal staircase for the pharaoh's soul to climb to join the sun god Ra. For the Maya, each level represented a different plane of existence, from the underworld to the heavens, with priests ascending to commune with the gods. In China, the tiers symbolized the hierarchical steps to celestial order and imperial authority. The pyramid became a cosmic ladder. What is truly captivating is the divergence that followed this shared beginning. In Egypt, the stepped pyramid was a prototype. Engineers soon filled in the steps with stone casing to create the smooth, iconic slopes of the Giza pyramids. Yet in Mesoamerica, the step design remained the definitive form for centuries, integral to their temple architecture. This tells us something crucial. Different cultures arrived at the same fundamental solution, the stepped layer, and then adapted it to their own unique aesthetic and religious needs. Was this a case of different minds solving the same problem identically, a convergent evolution of architecture? Or does the global prevalence of this specific, complex design hint at a foundational piece of knowledge, a core element of an ancient architectural blueprint that was understood across the world? These stone giants did not merely point toward the heavens, they were designed to actively track them, functioning as colossal stone calendars and observatories. The celestial connections we find are not vague or symbolic. They are precise, repeatable, and engineered into the very fabric of these structures. In Egypt, the 3 great pyramids of Giza are laid out on the ground in a pattern that mirrors the 3 stars of Orion's belt. This was not a chance arrangement. The relative positions and even the brightness of the stars are reflected in the sizes and layout of the pyramids, creating a perfect terrestrial map of a celestial constellation. This alignment connected the pharaohs with Osiris, the god of the afterlife, who was himself associated with the Orion constellation. It was a way of permanently anchoring their divine journey in the night sky. Across the world, in ancient Mesoamerica, the focus was on the sun. The Pyramid of the Sun at Teotihuacan is aligned so that its western face points directly to the setting sun on the days of its zenith passage, when the sun is at its highest point overhead. The entire city of Teotihuacan is laid out on a grid precisely angled 15.5 degrees east of true north, an alignment that seems to track the Pleiades star cluster. At Chichen Itza during the spring and fall equinoxes, a spectacular play of light and shadow occurs on the great stepped pyramid known as El Castillo. The setting sun casts a series of triangular shadows down the northern staircase, creating the illusion of a massive, undulating serpent slithering down from the temple at the summit. This was a dramatic, public demonstration of the pyramid's power to mark the cosmic cycles that govern planting and harvest. In China, the ancient mounds also show clear astronomical intent. Many of the pyramids near the old capital of Xi'an are aligned with various cardinal and intercardinal directions, corresponding to significant constellations in Chinese star lore. These constellations were not just patterns of light, they were the celestial bureaucracy, a heavenly mirror of the imperial court on earth. By aligning their monumental tombs with these stars, the emperors were asserting their role within a cosmic order, their authority sanctioned by the heavens themselves. This shared architectural language reveals a universal human impulse to synchronize earthly life with celestial rhythms. How did they achieve such precision? Corridors and shafts within the pyramids were not just passages for the dead. In the Great Pyramid, narrow shafts emanating from the king's chamber point directly toward the stars of Orion and the circumpolar stars that never set, perhaps intended as a conduit for the pharaoh's soul. In many Mesoamerican temples, doorways and windows were positioned to frame the rising sun on the solstice. These were not random openings, they were precisely calibrated instruments of stone. The sheer accuracy of these alignments required generations of patient observation, the development of sophisticated mathematics, and an unwavering belief that the patterns in the sky were intimately connected to life on the ground. This global fascination with celestial synchronization points to a profound, shared question. Were these cultures simply responding to the same visible cosmos with the same intellectual curiosity, or does the repetition of such specific, complex alignments suggest a deeper, more mysterious connection? Hidden within the stone and earth of these monuments is a silent language, a code of numbers and shapes that repeats across the globe. This is the language of sacred geometry, and its most famous key is the golden ratio. Represented by the Greek letter phi, approximately 1.618, this ratio is found throughout nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. It is a proportion that the human eye perceives as inherently balanced and beautiful. The Great Pyramid of Giza is a stunning example of this principle in stone. The ratio of its total surface area to the area of its base is almost exactly the golden ratio. This is not a coincidence. It is a deliberate design choice, embedding a fundamental law of nature into the very shape of the pyramid. Far across the world, the Maya achieved a similar mathematical feat. The Pyramid of Kukulkan at Chichen Itza is not a simple triangle. Its design is a complex interplay of terraces, staircases, and levels, and the proportions between these elements often resolve to the same harmonious ratio. Even the great earthen pyramids of China, though their outer forms have been softened by centuries, show through their foundational layouts that they were planned with precise, consistent proportions governing their width to their height. This points to a shared architectural intuition for what is both pleasing to the eye and stable in construction. This mathematical consistency extends to a specific, powerful angle. Many of the world's most famous pyramids, from Giza to others we have studied, feature slopes angled between 51 and 52 degrees, Why this specific angle? It represents a perfect equilibrium. A steeper angle would risk collapse under immense weight, while a shallower one would require an impractically wide base and an overwhelming volume of material. The 51-degree slope is the geometric sweet spot, a naturally stable form that allows a structure to reach for the sky while remaining firmly anchored to the earth. It is the angle of optimal stability, discovered and applied by builders who never met. But for these ancient cultures, numbers were far more than practical tools. They were the building blocks of the cosmos itself. The golden ratio was not just a formula for a pretty shape. It was seen as a divine proportion, a visual representation of the harmony between the earthly and the spiritual realms. To build a pyramid using this ratio was to infuse it with cosmic order, to make it a physical manifestation of universal balance. This spiritual dimension transforms the pyramid from a mere building into a sacred object, its geometry a prayer in stone. So we are left with a profound question. Did cultures from Egypt to the Americas to China all independently stumble upon the exact same complex mathematical principles and their spiritual significance? Or does this recurring code of sacred geometry point to a different possibility, a single, ancient, and now lost source of knowledge that understood the fundamental mathematics of our world and spread this blueprint far and wide? But the true genius of these structures is often hidden from view. Deep within the stone and earth, a complex network of internal spaces repeats across continents, revealing a fifth and perhaps most telling architectural parallel. The Great Pyramid of Giza is a labyrinthine masterpiece inside, far more than a simple tomb. It contains a series of chambers, including the magnificent King's Chamber built from massive granite blocks, connected by a long, ascending passageway known as the Grand Gallery. Narrow shafts, once believed to be for ventilation, pierce the masonry, pointing precisely toward specific stars. This was architecture designed not just for the body, but for the soul's celestial journey. In Mesoamerica, the pyramids tell a different kind of internal story. The Temple of the Inscriptions at Palenque houses the elaborate tomb of the ruler Pakal deep within its core. To reach it, one must descend a long, internal staircase sealed for over 1,000 years. At other sites, like the Great Pyramid of Cholula, archaeologists have discovered that the massive final structure is actually a series of nested pyramids, one built over the other like a set of Russian dolls. Each new layer encapsulated and preserved the sacred chamber of the previous temple, honoring the past while building for the future. In China, the Great Earthen Pyramids, though largely unexcavated to protect them, have revealed through limited surveys and historical accounts the presence of deep burial chambers, intricate passageways, and underground palaces filled with treasures, all sealed beneath immense tons of packed earth. The engineering required to create these hollow spaces within such colossal structures was immense. How do you prevent 1,000,000 tons of stone from collapsing inward? The answer was a shared architectural innovation, the Corbeled arch. This technique involves stacking layers of stone, each one projecting slightly inward over the one below, until the gap at the top can be sealed with a single capstone. It is a self-supporting structure, a brilliant solution to distributing immense weight away from the open space below. Builders in Egypt, the Maya, and China all used variations of this same method to create stable, lasting chambers. Why would such specific and complex internal designs appear so widely? Were these simply the logical conclusions of any culture trying to build a large, stable interior room? Or does the repetition of nested construction, precise star shafts, and deep, hidden tombs point toward a shared architectural philosophy, a blueprint for the sacred interior that was as important as the sacred exterior shape? This internal evidence moves us beyond the realm of simple coincidence and into something far more deliberate. This shared architectural philosophy extends even to the very substances from which these giants were born. The core blueprint remained constant, yet its execution was a masterclass in local adaptation, a testament to the ingenuity of engineers working with what their land provided. In Egypt, the primary material was stone, and not just any stone. The Great Pyramid's core consists of massive blocks of local limestone, quarried right from the Giza plateau. For the inner chambers and the dazzling outer casing, they hauled granite over great distances, a stone so hard it required incredible effort to shape. This was a civilization that mastered stone cutting, achieving near-perfect joints that fit together with breathtaking precision. Across the Atlantic, the Maya of Mesoamerica also built in stone, but their approach was brilliantly different. Their pyramids often had a core of rubble, loose stones, and earth, which was then encased in a stable retaining wall and finished with a thick, smooth layer of painted stucco. These structures were not the stark, geometric mountains of Egypt, but vibrant, colorful temples, their surfaces often adorned with elaborate murals and carvings. Meanwhile, in the plains of China, the Great Pyramids took on an entirely different character. Here, the primary building material was earth itself. Using a technique known as rammed earth, workers would layer damp earth into wooden frames and then pound it with heavy tools into an incredibly dense, hard, and durable mass, almost like man-made rock. These earthen cores were then sometimes faced with brick or stone for additional protection and a finished appearance. The construction methods were as varied as the materials. In Egypt, we see the use of massive ramps and sledges to move colossal blocks into place. In Mesoamerica, construction was often additive, with new layers built directly over older structures using vast amounts of human labor to transport materials without the wheel or draft animals. In China, the rammed earth technique was a slow, methodical process of building up the mound layer by compacted layer. So why, if the materials and methods were so different, do we see the same enduring stability? The answer lies in a universal understanding of physics and geology. Each culture chose the most stable and available material for their environment. The Egyptians used the bedrock itself as a foundation and built with stone that could withstand the desert's dry climate. The Maya used a lighter rubble core that could better withstand seismic activity in their region, finished with a protective stucco shell against the jungle rains. The Chinese used packed earth, a material that, when constructed correctly, becomes monolithic and incredibly resistant to the elements, forming mounds that have weathered millennia. This reveals a crucial truth about the pyramid blueprint. It was not a rigid set of instructions demanding specific stones. It was a flexible principle of sacred geometry and monumental stability that could be realized in limestone, in stucco-covered rubble, or in packed earth. The genius was not in copying a material, but in understanding the underlying goal, a goal so powerful it could be built from the very soil beneath their feet. How did this same flexible genius emerge in such isolated parts of the world? Stone and earth alone could never account for the enduring power of these monuments. Their true essence lies in the beliefs they embodied, a shared spiritual purpose that transcended geography and culture. For the ancient Egyptians, the pyramid was a resurrection machine. It was not merely a tomb for a dead king, but a device to propel the pharaoh's soul into the afterlife. They believed the structure's sloping sides would act as a ramp, allowing the divine ruler to ascend and join the sun god Ra in his eternal journey across the sky. The entire pyramid complex, with its mortuary temples and causeways, was a carefully orchestrated landscape for this cosmic transition, ensuring order and stability for the entire kingdom. Far across the world, in the heart of Mesoamerica, pyramids served a different but equally vital function. They were not sealed tombs but vibrant stages for public ritual. High atop their steep stairways, priests would perform ceremonies of sacrifice and offering to appease gods of rain, sun, and maize. The pyramid temple was the meeting point between the human community and the divine forces that controlled their survival. The blood spilled on its summit was believed to nourish the gods themselves, maintaining the cosmic balance and preventing the world from falling into chaos. In China, the great earthen pyramids served as imperial mausoleums, linking the emperor's authority directly to the heavens. The ruler was the son of heaven, and his burial within these colossal mounds was the final act of a sacred covenant. The pyramid did not launch his soul on a journey. Instead, it permanently anchored his power and wisdom within the earth, affirming his dynasty's mandate to rule in harmony with the celestial order. These were not just graves, they were assertions of a divine right that extended beyond death. Beneath these distinct practices lies a common thread so fundamental it seems etched into the human psyche, the sacredness of the mountain. From the solitary peaks where Greek gods resided to the Himalayan abodes of Hindu deities, mountains have universally been seen as the homes of gods, the sources of life-giving rivers, and the points where heaven and earth touch. But what happens when a civilization lives on a flat plain, or in a dense jungle without a commanding natural peak? They build their own. The pyramid is the ultimate artificial mountain, a human-made axis mundi designed to access the same spiritual power. This idea finds its deepest roots in the concept of the primordial mound. In Egyptian mythology, the very first land emerged from the infinite waters of chaos as a pyramidal mound, the Benben. The pyramid was a recreation of this sacred moment of creation. Similarly, Mesoamerican creation stories often speak of a sacred mountain where the first humans were formed from maize. The Pyramid Temple was this mythic mountain made real. Even in China, the pyramid's form echoed the legendary Mount Kunlun, the axis of the world and the home of the immortals. So we see a stunning convergence. Cultures that never met all looked to the same geometric form to answer the same profound human needs, to bridge the gap between the mortal and the divine, to bring cosmic order out of chaos, and to secure the favor of powers beyond their control. The pyramid was more than architecture. It was a physical prayer, a shared human solution to the mystery of existence itself. The timeline of these structures presents a puzzle that refuses to fit neatly into our history books. The Great Pyramids of Egypt rose to their zenith around 2,500 years before the Common Era. Then, roughly 1,500 years later, the first Great Pyramids began to appear in Mesoamerica. In China, major pyramid construction for the early emperors commenced just a few centuries after that. These are not gaps of millennia, but of centuries, a blink in the grand scale of human civilization. How could such a complex architectural and spiritual concept emerge on three separate continents within this relatively compact window of time, with no record of contact between the builders? This question divides scholars into two distinct camps. On one side are those who argue for independent invention. They see the pyramid as the natural, almost inevitable result of any society's architectural evolution. The simplest form of a monument is a mound. As societies become more complex and want to build taller, the mound naturally evolves into a stepped platform for stability, and then into a true pyramid. This was a logical progression of engineering, a solution waiting to be discovered by any culture that sought to build grand, stable, and symbolic structures. The different materials and construction methods used in Egypt, the Americas, and China are, for this group, the strongest evidence that each culture developed its own unique path to the same brilliant conclusion. It was a case of convergent cultural evolution, where similar social and spiritual needs produced a similar architectural form. On the other side are the diffusion theorists, who find the parallels too precise to be mere coincidence. They point not just to the general pyramid shape, but to the specific shared details we have already explored: the precise cardinal alignment, the recurring 51-degree slope, the use of internal chambers and corbelled arches, and the deep integration of sacred geometry and astronomy. Could all of these complex elements really have been independently discovered, not once but 3 times? For these researchers, the timeline, while not perfectly overlapping, leaves just enough room for the possibility of knowledge transfer. Could a forgotten seafaring culture have carried the basic blueprint across the oceans, a seed of an idea that then took root and flourished in different soils, adapting to local materials and beliefs? The absence of any clear archaeological evidence for such a transfer, like shared artifacts or inscriptions, is the greatest challenge to this theory. Yet proponents argue that ideas are the most potent cargo, and they can travel without leaving a physical trace in the archaeological record. Complicating the puzzle further is the spotty evidence of transitional forms. In Egypt, we can trace a clear evolution from the simple mastaba tomb to the stepped pyramid of Djoser, and finally to the smooth-sided giants of Giza. This is a textbook case of architectural development. In Mesoamerica, however, the record is less linear. While there are earlier platform mounds, the appearance of the classic stepped pyramid can seem, in some regions, to arrive in a more fully realized form. This missing link in the chain of development is a tantalizing gap that keeps the debate alive and fiercely contested. So where does this leave us? Are we looking at the ultimate proof of the human mind's universal creative spirit, solving the same grand problem in identical ways across the globe? Or are we seeing the faint, fragmented echoes of a single, ancient source of knowledge, a lost chapter in human history where the world was far more connected than we ever believed? The stones themselves hold the answer, but they have yet to give up their final secret. These monuments rise from radically different worlds. The stark Egyptian desert, the humid Mesoamerican rainforest, and the sprawling Chinese plains represent a breathtaking range of environments. Yet beneath this surface diversity lies a profound geographical pattern. Each of these pyramid-building cultures chose remarkably similar locations for their greatest works. They consistently settled in fertile river valleys and basins, landscapes rich with agricultural potential. The Nile, the Valley of Mexico with its lake system, and the Wye River Valley in China were all breadbaskets, capable of producing the massive food surpluses needed to feed the thousands of laborers and artisans who would devote their lives to construction. Without this foundational agricultural wealth, the pyramids could never have been conceived. The sites themselves were not chosen merely for convenience. They were selected with a sacred eye, following principles of landscape architecture that viewed the earth as a living, spiritual entity. Pyramids were often positioned in a deliberate relationship with powerful natural features. In Egypt, the pyramids at Giza are not just on a plateau. They are aligned with the Nile's course, mirroring the celestial river of the Milky Way in a grand terrestrial cosmic map. In Mesoamerica, the Pyramid of the Sun at Teotihuacan was built directly over a natural cave system, a portal to the underworld that infused the man-made mountain with primordial power. In China, many imperial mounds were carefully sited to face a particular mountain or river, their placement ensuring harmony with the local spirits and the flow of natural energy, or Kai. The environment dictated the method, but never the core form. The Egyptians living in a stone-rich desert, built for eternity in limestone and granite. The Maya, in a land of frequent earthquakes and heavy rain, developed a flexible rubble core and protective stucco finish. The Chinese, on the soft lowest plains, mastered the art of rammed earth, creating mounds that have endured for thousands of years. This geographical spread is a testament to the blueprint's incredible adaptability. It was a universal concept of sacred geometry and monumental presence that could be realized anywhere, from the most arid desert to the luscious jungle, proving that the impulse to build a bridge to the heavens was not bound by climate, but was a fundamental part of the human journey. The numbers etched into these monuments speak a language far more precise than words. Within the Great Pyramid's dimensions, a startling relationship emerges. If you take the pyramid's perimeter and divide it by twice its height, the result is a figure astonishingly close to pi, the mathematical constant representing the ratio of a circle's circumference to its diameter. This was not a random occurrence. It suggests the builders intentionally encoded this fundamental constant into the very shape of their structure, a concept Western mathematics would not formally define for another 2,000 years. This same pyramid's proportions also embody the golden ratio, a harmony found in nature's own designs. Far across the world, Mesoamerican builders were weaving a different kind of mathematical magic. Their pyramids were not just temples but colossal calendars in stone. The Pyramid of Kukulkan at Chichen Itza has 4 stairways, each with 91 steps. When you add the final step to the top platform, you get 365, a direct representation of the solar year. The entire structure is a complex astronomical computer, its shadows and alignments marking the equinoxes and solstices with theatrical precision. In China, the earthen pyramids, though their outer forms have softened, reveal through their foundations and burial complexes a rigorous adherence to geometric planning and standardized proportions, a systematic approach to monumental scale. How did these separate cultures achieve such mathematical sophistication? The answer lies in generations of patient observation. They were not working from abstract theorems but from practical, repeated measurement of the world around them. The Egyptians likely discovered their pi relationship through the simple act of rolling a drum, measuring how many diameters fit around a circumference. The Maya developed their calendar mathematics by meticulously tracking the cycles of the sun, moon, and Venus over centuries. This practical knowledge was then elevated into sacred architecture, transforming stone into a permanent record of cosmic law. This mathematical genius was matched only by their engineering audacity. Moving multi-ton stone blocks across miles of desert or jungle without the wheel or pulleys seems impossible. Yet they developed ingenious solutions. The Egyptians used massive sledges gliding on tracks wet with water to reduce friction, hauling stones up colossal earthen ramps that snaked around the rising pyramid. The Maya, without metal tools, shaped hard limestone using harder stone tools and abrasives, then transported the rubble and fill using vast human chains. The Chinese, building with rammed earth, perfected a process of compaction that turned simple soil into a material as durable as stone, building their mounds layer by painstaking layer. The true test of their engineering, however, is time itself. These structures have endured for thousands of years, surviving earthquakes, climate shifts, and the slow erosion of centuries. Their stability comes from a deep, intuitive understanding of load distribution and foundational integrity. The precise 52-degree angle common to so many pyramids is not just a sacred number. It is the angle of repose for stacked stone, the naturally stable slope that prevents collapse. They built not for a generation but for eternity, and their success is a silent testament to their skill. This global harmony of number and form forces a difficult question. Were these cultures all independently discovering the same immutable truths of mathematics and physics, a convergent evolution of the human intellect? Or does the sheer consistency of their application, from pie in the desert to calendar steps in the jungle, point toward a shared, ancient well of knowledge from which they all drew? The stones hold the equations, but the source of the code remains one of history's deepest mysteries. For centuries, the true secrets of these pyramids were locked within their stone and earth, impervious to our questions. But now, a technological revolution is allowing us to peer inside without lifting a single stone. Ground-penetrating radar sends pulses of energy deep into the earth, mapping hidden chambers and voids by measuring how the signals bounce back. In Egypt, this technology has revealed a previously unknown, airplane-sized void deep within the Great Pyramid, a tantalizing mystery that archaeologists are still working to interpret. Meanwhile, in the dense jungles of Guatemala and Mexico, LiDAR technology has been a game-changer. By firing laser pulses from aircraft and measuring their return, LiDAR strips away the forest canopy to reveal the ground beneath, exposing the full, breathtaking scale of ancient cities. It has shown us that what we thought was a single, isolated pyramid was often the final layer of a much larger complex, with entire earlier temples and plazas buried beneath. These digital maps have revealed networks of roads, reservoirs, and construction camps that rewrite our understanding of how these societies organized their monumental building projects. Three-dimensional modeling then brings these discoveries to life, allowing us to virtually reconstruct the step-by-step sequence of construction to see how a pyramid grew over centuries. This non-invasive approach has proven a crucial truth. The practice of building in layers was a global phenomenon. The Great Pyramid of Cholula in Mexico is not one pyramid, but at least 6, each new layer encapsulating the last like the rings of a tree. We see this same pattern in Egypt, where earlier structures are often found beneath the colossal foundations at Giza, and in China, where early reports suggest similar nested construction within the great earthen mounds. The evidence points to a shared architectural philosophy, where these sites were so sacred that new construction honored the past by building directly upon it. The archaeology of the people who built these wonders is equally revealing. Excavations of worker settlements near the Giza Plateau paint a picture not of slaves, but of skilled, well-fed laborers organized into teams with telling names like the Friends of Khufu. They were housed in massive, planned communities with bakeries, infirmaries, and even breweries, all supported by the state. At the Maya site of Tikal, similar studies of the surrounding landscape show a vast, mobilized population capable of supporting the intense labor required to build the towering temples. The organizational blueprint for managing these immense workforces, from quarry to construction site, appears strikingly similar across cultures, a logistics operation of breathtaking scale and efficiency. Material science adds another layer to the puzzle. Analysis of the limestone at Giza shows the builders had an intimate knowledge of the local geology, selectively quarrying specific layers of stone for specific purposes. The Maya developed a complex lime plaster for their stucco that was incredibly durable and resistant to the humid jungle environment. The Chinese rammed earth technique was not just piling dirt, it was a precise science of soil composition and moisture content, compacted to create a man-made bedrock. Each culture displayed a masterful, localized understanding of their materials, proving the blueprint was adaptable to any environment. Yet for all these advances, profound mysteries remain. Many of China's most significant pyramids, considered sensitive cultural relics, have been largely untouched by the archaeologist's trowel. What hidden chambers, what construction records, what final answers lie sealed within those earthen mounds? The evidence we have gathered so masterfully supports both sides of the debate, revealing both universal patterns and distinctly local adaptations. every new scan, every new map, brings us closer to understanding whether we are witnessing the independent genius of humanity or the scattered fragments of a single, forgotten source. The stone itself tells a story written not by human hands, but by millennia of rain and wind. Geological evidence is now challenging our timelines, suggesting these monuments may have witnessed climates far different from the deserts and jungles we see today. The most famous clue lies not on a pyramid but beside one. The Great Sphinx of Giza, carved from the living bedrock, shows deep, vertical fissures of erosion on its body and enclosure walls. Geologists argue this specific pattern is the unmistakable signature of heavy, prolonged rainfall, not the wind-blown sand of the desert. For such erosion to occur, the Sphinx must have stood during a time when the Egyptian climate was significantly wetter, pushing its possible construction date back thousands of years earlier than the standard chronology suggests. This is the water erosion hypothesis, and if correct, it rewrites the history of one of the world's most iconic monuments. But this story of water is not confined to Egypt. On the other side of the world, the limestone facades of ancient Mesoamerican pyramids, like those at Tikal, also bear erosion marks that tell a tale of climatic shifts. The patterns suggest these structures endured periods of even more intense tropical rainfall than the region experiences now, followed by eras of relative dryness. How do we read this stone ledger? Scientists drill core samples from nearby lake beds and analyze the layers of sediment. Each layer is a time capsule, preserving pollen, dust, and chemical isotopes that reveal the precise climatic conditions of each century. By matching the erosion patterns on the pyramids to these detailed climate records, we can begin to reconstruct the very world the builders lived in. Was a particular pyramid in Egypt raised during a brief, wetter phase in an otherwise arid epoch, giving workers access to more water for mixing gypsum mortar and for their own survival? Did the Maya construct their grandest temples during a peak period of reliable monsoon rains, when agriculture flourished and could support a massive workforce? The materials they chose suddenly make more sense in this climatic context. The Egyptian reliance on stone was not just a matter of availability. It was a response to an increasingly dry environment where only the most durable material would last. The Maya's thick, protective stucco coatings were a direct defense against a relentlessly wet and humid climate that would quickly dissolve weaker surfaces. Even the Chinese mastery of rammed earth can be seen as an ideal adaptation to the deep, stable lower soils of the plains, soils formed by wind-blown dust during ancient dry periods. The weathering of these different materials provides another clock. By studying how deep the erosion channels are cut into a pyramid's side, or how much the original cornerstones have rounded, geologists can create relative chronologies. A pyramid showing more severe water erosion than its neighbor, despite being made of the same stone, might silently testify to being the older structure, having endured centuries of a forgotten wet climate. This geological evidence pulls the thread on our entire timeline. If the Sphinx is far older, does that mean the pyramid-building tradition itself has roots in a much more ancient, climatically different Egypt? When we see similar erosion patterns on early Mesoamerican structures, does it suggest that these civilizations were developing their monumental architecture contemporaneously with a much older Egyptian culture, rather than millennia later? Or does it simply mean that both regions experienced similar cycles of climate change at different times, and each culture's pyramids bear the unique scars of their own environmental battles? The stones are speaking, and their story is one of water, wind, and time, forcing us to listen to a history far more complex and interconnected than we ever imagined. The stones of these ancient monuments hold secrets beyond what the eye can see or the hand can touch. A new dimension of this mystery is now coming to light, not in their form but in their sound. Recent explorations have uncovered that many pyramids were not just silent tombs but were engineered to be deeply resonant instruments. In the heart of the Great Pyramid, the so-called King's Chamber, built from massive granite blocks, possesses a unique acoustic character. The precise proportions and hard, smooth surfaces of the room cause sound to behave in strange ways, creating a lingering resonance that seems to amplify certain frequencies, a phenomenon that would have profoundly altered the experience of any ritual performed within its walls. This was not a flaw in construction, it was a feature. Across the ocean, the evidence becomes even more theatrical. On the Great Stepped Pyramid of Kukulkan at Chichen Itza, if you stand at the base of the massive staircase and clap your hands, the sound that returns is not a simple echo. It is a sharp, chirping cry that precisely mimics the call of the revered Quetzal bird, a sacred creature associated with the serpent deity for whom the pyramid is named. This is not a random acoustic accident. The sound is created by the precise spacing and angle of the steps, which break the clap into a rapid series of reflections. The builders engineered the entire staircase to function as a diffraction grating for sound, a sophisticated acoustic device carved in stone. Even the great earthen pyramids of China, long thought to be mute mounds, are now the subject of preliminary studies that suggest they, too, may have been designed with sonic properties in mind, their internal chambers and passages potentially tuned to specific resonant frequencies. The intentional manipulation of sound required a sophisticated understanding of physics. To create the Quetzal bird echo, Mayan architects had to calculate the exact relationship between the time delay of the sound bouncing off each step and the resulting pitch. In Egypt, selecting granite for the King's Chamber was a conscious acoustic choice, as its density and crystalline structure produce a much clearer and longer-lasting resonance than the surrounding limestone. This was an advanced science of sonic geometry. Why would these cultures go to such extraordinary lengths? The answer lies in the ceremonial power of sound. In sacred rituals, sound was not just background noise, it was a direct conduit to the divine. The deep, resonant frequencies in an Egyptian burial chamber could induce altered states of consciousness, perhaps aiding the pharaoh's spiritual transition. The miraculous cry of the Quetzal bird echoing from the Maya temple was a public demonstration of the god's presence, a voice from the stone itself affirming the priest's connection to the heavens. Sound could shape spiritual experience in a way that sight alone never could. So we are faced with yet another parallel, another shared piece of a complex architectural blueprint. Did priests and architects in Egypt, the Americas, and China all independently discover the same principles of acoustic resonance and then, independently, decide to build them into their most important monuments? Or does this shared attention to crafting sacred sonic environments point toward a common, and now lost, understanding that true power lay in the marriage of form, alignment, and sound? The echo that returns to us across the centuries seems to be asking a question of its own. The stones of these pyramids might do more than simply echo sound. They may also channel invisible forces. Beyond the acoustic wonders, a more subtle mystery hums within their walls, one that modern science is just beginning to measure. Researchers have discovered that the Great Pyramid of Giza can concentrate electromagnetic energy, not throughout its entire mass, but specifically within its hidden chambers and beneath its apex. Sophisticated models show that the pyramid's unique geometry causes radio waves to gather in these specific internal spaces, and at its peak, as if the entire structure were a kind of lens focusing unseen energy. This is not magic, it is physics, a property arising from its perfect proportions and the resonant qualities of its limestone and granite. similar energy anomalies appear halfway across the world. At ancient Mesoamerican sites, visitors and researchers have long reported that standard compasses often behave erratically, their needles wavering unpredictably instead of pointing steadily north. More precise instruments have confirmed localized electromagnetic distortions around these temples, suggesting the ground itself or the massive stone piles are generating or altering magnetic fields. Even the great earthen pyramids of China, though far less studied, are not exempt from these peculiar reports, with some preliminary surveys hinting at unusual magnetic signatures that distinguish them from the surrounding plains. What could cause such widespread yet specific electromagnetic phenomena? The explanations are as varied as the structures themselves. It could be the unique mineral composition of the stones used, with certain rocks containing magnetic properties that interact with the Earth's field. It might be the sheer mass and specific geometry of the pyramids, their shape channeling natural background energy in unexpected ways. Another compelling theory points to the water table, suggesting that underground rivers or aquifers flowing beneath these monuments create subtle electrical currents that the pyramid form then amplifies. This leads to a profound and controversial question. Did the ancient builders stumble upon these properties by accident, or did they understand them? Could they have intentionally designed these structures not just as spiritual bridges, but as functional power plants or energy amplifiers? The precision of their celestial alignments and sacred geometry suggests a deep knowledge of natural law. Is it so far-fetched to think they might have also understood the Earth's hidden energies and learned to build conduits for them? Whether a stunning coincidence or the mark of forgotten science, these shared electromagnetic characteristics weave another thread into the global tapestry. The pyramid form appears not only as a map of the sky and a ladder for the soul, but perhaps also as a silent stone antenna, still humming with a power we are only now learning to detect. Behind the stones and earth, a different kind of structure was essential, the invisible framework of human society. To build these giants, these cultures first had to build something equally impressive. A highly organized social machine capable of feeding, housing, and directing thousands of people for generations. The archaeological record reveals a stunning parallel in how these workforces were managed across the world. Near the Giza plateau, excavations have uncovered entire towns built for the pyramid workers. These were not squalid slave camps but planned communities with orderly streets, large bakeries capable of producing thousands of loaves of bread each day, facilities for curing fish, and even breweries for beer. The workers were organized into competing crews with names like the Friends of Khufu or the Drunkards of Menkara, a system that fostered team spirit and efficiency. They received medical care, as evidenced by skeletons showing healed fractures that were expertly set, proving they were valued laborers, not disposable slaves. This was a hierarchical system with specialized roles, from master quarrymen and skilled stonemasons down to the laborers who hauled the blocks, all coordinated by a sophisticated bureaucracy of scribes and overseers. In Mesoamerica, the social organization took on a different, yet equally effective character. While there was certainly a ruling class of priests and nobles directing the work, construction often involved massive community participation. Building a temple pyramid was a sacred duty, a collective ritual that reinforced social bonds and honored the gods who ensured the rains would come and the maize would grow. Imagine entire communities gathering for these projects, with different neighborhoods or family groups responsible for contributing a certain amount of labor or materials. This created a shared investment in the monumental symbol at the heart of their city. The Chinese imperial mounds required a similar, if not greater, level of centralized control. Historical accounts describe how emperors would mobilize hundreds of thousands of subjects for these projects, a logistical feat that demanded an advanced administrative state. Officials had to coordinate the sourcing of earth, the manufacturing of tools, the construction of ramps, and the provisioning of this colossal army of labor. The workers would have been compensated with food, shelter, and perhaps a release from other tax obligations, all managed through a rigid, top-down hierarchy that mirrored the empire's own structure. The methods of compensation and housing show both clear similarities and fascinating cultural variations. In all three cases, the state provided sustenance, but the Egyptian worker villages represent a form of direct, state-run welfare on a massive scale. In Mesoamerica, compensation may have been more spiritual and social, woven into the fabric of religious obligation and community status. In China, it was an imperial decree, a demand of the state that was both a burden and a duty for its citizens. This organizational parallelism is perhaps the most telling clue. It indicates that the pyramid form did not simply emerge wherever people learned to stack stones. It appeared specifically in societies that had reached a critical threshold of social complexity, developing the political centralization, administrative sophistication, and economic surplus necessary to envision and execute projects spanning decades, even centuries. They each invented the same social machinery to build their cosmic mountains, proving that the true blueprint was not just for stone, but for society itself. These individual pyramids were not isolated points on the map. They were nodes in a vast, invisible network, connected to other ancient megalithic sites through lines of sight and precise geographical alignments that stretch across entire continents. In Egypt, the three Great Pyramids of Giza are not only a mirror of Orion's belt, but their placement also creates alignments with the distant temple complex of Heliopolis, the religious center of the sun cult. Some researchers have drawn lines across the Mediterranean, suggesting the Great Pyramid itself sits on a significant longitudinal marker, a kind of prime meridian for the ancient world, with potential alignments reaching as far as Stonehenge in Britain. While these long-distance connections are debated, the principle of intentional placement is undeniable. The pyramids were designed to be seen in relationship with other sacred features of the landscape. In Mesoamerica, this interconnected design is even more explicit. The entire city of Teotihuacan was laid out as a precise scale model of the solar system. The Pyramid of the Sun, the Pyramid of the Moon, and the Temple of the Feathered Serpent are positioned to represent different celestial bodies, with the long central avenue acting as the ecliptic path. From the summit of one pyramid, a priest could sight across to another, marking the rise of a specific star or the sun's position on the horizon. This was not just city planning, it was cosmic cartography etched into the earth. The great earthen pyramids of China's Shaanxi province also whisper of a larger plan. Many are clustered near the ancient capital of Xi'an, and their locations appear to correspond to significant constellations in Chinese astronomy, forming a terrestrial map of the heavenly court. Some alignments even suggest a relationship with the sacred Mount Lai, the legendary tomb of the first emperor, Qin Shi Huangdi, creating a sacred geography that linked imperial power to both the stars and the most powerful natural landmarks. This pattern of connecting man-made mountains to natural ones, to rivers, and to other distant monuments is a thread that runs through every pyramid-building culture. It reveals a worldview where the entire landscape was alive with spiritual meaning, and where building a pyramid was an act of inserting a sacred marker into a pre-existing web of power points. The question this raises is profound. Did these cultures, working independently, all arrive at the same complex conclusion that their monuments needed to be part of a grand, geographically coordinated system. Or do these continent-spanning alignments hint at a level of global awareness and planning that conventional history has completely missed? The silent relationships between these stones suggest our ancestors saw the world not as separate continents, but as a single, interconnected sacred whole. This simple, powerful form was a vessel for humanity's deepest aspirations. The pyramid was far more than a shape. It was a three-dimensional symbol, its geometry speaking a universal language of ascension, stability, and connection. Its pointed peak naturally draws the eye upward, a physical metaphor for the soul's journey from the earthly realm toward the celestial. Its impossibly wide, solid base roots it firmly to the ground, representing an unshakable foundation, a promise of order and permanence in a chaotic world. And the entire structure, rising from that square earth to that singular point in the sky, becomes the ultimate bridge, the axis where heaven and earth meet. In Egypt, this symbolism was explicit and functional. The pyramid was a resurrection machine designed to project the pharaoh's soul. Its smooth, gleaming sides were seen as a ramp of light, a literal pathway for the divine king to climb and join the sun god Ra in his eternal cycle, ensuring his power would continue to sustain the kingdom from the stars. Across the ocean, the Mesoamerican pyramid embodied a different yet parallel cosmic vision. It was the sacred world mountain, a concept found in creation myths across the region. Its stepped levels did not represent a smooth ascent, but distinct planes of existence. The dark interior chambers and the base connected to the watery underworld. The main platform was the realm of human life, and the summit temple was the domain of the gods. Priests ascending the steep stairways were reenacting this cosmic geography, moving between worlds to commune with deities and maintain the balance of the universe. Meanwhile, in China, the great earthen pyramids carried a profound political and cosmic symbolism. The emperor was the son of heaven, and his burial mound was a permanent, monumental statement of that divine mandate. The pyramid's form symbolized the perfect hierarchical order of the cosmos, with the emperor at its apex, connecting the earthly bureaucracy to the celestial one. Its quiet, imposing presence on the landscape was a constant reminder of imperial authority and the harmony between human rule and the natural world. What is truly compelling is how this shared symbolic meaning unfolded within such different religious contexts. The Egyptians focused on a single soul's stellar journey, the Mesoamericans on a layered cosmos sustained by ritual, and the Chinese on a hierarchical social order mirroring the heavens. Yet all three looked at the same geometric form and saw the same fundamental truths: ascension from the mundane, stability through divine order, and a tangible connection to the powers above. This consistency points to something deeper than cultural exchange. It suggests that the pyramid form somehow taps into a fundamental layer of the human psyche, a collective intuition about what is sacred. Its geometric perfection, its undeniable balance and harmony, seems to resonate with an innate human understanding of cosmic order. The form itself feels eternal, a perfect marriage of mathematical truth and spiritual yearning. So we are left to wonder, does the pyramid's enduring power come from a set of ideas that simply occurred to every advanced culture, a convergent evolution of the human spirit? Or does its universal symbolism hint that we are all responding to an ancient, embedded blueprint, one that speaks to a shared origin for our most profound dreams of order, meaning, and connection to the stars? The silent stones are finally beginning to speak, their secrets translated not by chisels but by cosmic particles. A scientific revolution is now underway, deploying technologies that peer through solid rock to reveal the hidden anatomy of these ancient giants. One of the most powerful of these new tools is Muon radiography. This ingenious technique uses muons, subatomic particles that constantly rain down from the atmosphere, much like a natural, invisible X-ray. As these particles pass through stone, they are absorbed at different rates depending on the density of the material they encounter. By placing sensitive detectors inside or around a pyramid, scientists can map where muons pass through easily, revealing hidden chambers and voids without ever touching a single stone. It was this very method that recently detected the startling, airplane-sized cavity deep within the Great Pyramid of Giza, a mysterious empty space that defies any simple explanation and hints at architectural features we never knew existed. From the subatomic scale, we zoom out to a planetary perspective, where satellites and drones are reshaping our understanding of the ancient landscape. High-resolution satellite imagery can detect subtle variations in soil moisture and plant growth, revealing the buried foundations of lost pyramids and the ghostly outlines of ancient processional roads leading to them. Drones equipped with thermal and laser scanners fly over dense jungle canopies, creating three-dimensional maps of the ground below. In Mesoamerica, this LiDAR technology has been particularly transformative, stripping away the forest to expose vast, interconnected urban centers organized around their pyramid temples. These aerial views show us that these monuments were never isolated. They were the hearts of elaborate, planned cities, with their alignments stretching out to connect with distant hills and other temples, forming a vast, sacred geometry across the entire region. When we analyze the very substance of the pyramids, the stones themselves tell a story of logistics and human endeavor. Using portable X-ray fluorescence spectrometers, researchers can now take a non-destructive reading of a stone block's chemical signature right on the spot. This allows them to match the stone to its exact quarry source. We can now trace the journey of a single limestone block from a specific quarry on the opposite bank of the Nile to its final resting place high in the Great Pyramid. This material fingerprinting reveals intricate supply chains and tells us the order in which different parts of the pyramid were built. We can see if builders ran out of one quarry and had to open another, creating a precise construction sequence locked in the chemistry of the stone. The story of the people who built these wonders is also being rewritten by science. DNA analysis of skeletal remains found in the worker cemeteries near Giza is revealing a workforce that was not only healthy and well cared for, but also surprisingly diverse. These genetic clues help us understand the origins of the laborers, showing they were not a homogeneous mass of slaves, but likely Egyptians from different regions, all contributing to a national project. Similarly, isotopic analysis of their teeth and bones can tell us what they ate and where they grew up, painting a vivid picture of the society that could mobilize and sustain such a colossal effort for generations. The true power of this scientific revolution lies in its ability to compare. For the first time, we can gather the same type of data from pyramids in Egypt, Mexico, and China. We can compare the geological sourcing strategies, the precise angles of internal chambers, the elemental composition of mortars, and the chronological development of construction techniques. This is creating a growing, global database of pyramid architecture. As this database expands, it allows us to move beyond speculation and toward evidence-based conclusions. The patterns that emerge will be undeniable. Either we will see a clear, convergent evolution of form and function, where each culture independently arrived at nearly identical solutions, or we will uncover a web of shared, specific techniques that defy the odds of chance. This is no longer about interpreting ancient texts or stylistic similarities. It is about hard data, about the physics of the void, the chemistry of the stone, and the biology of the builder. After thousands of years of silence, science is giving these monuments a voice. and what they are starting to say may rewrite the story of human civilization itself. These uncanny architectural echoes have ignited one of history's most enduring debates. Could these similarities be the scattered footprints of a single, advanced global civilization, a precursor culture lost to time? Proponents of this idea look at the shared blueprint and see more than coincidence. They see a common source, the precise cardinal alignment, the recurring 51-degree slope, the sophisticated use of sacred geometry, and the complex celestial tracking. These are not simple ideas. For this camp, such specific and advanced knowledge points to a shared teacher, a highly developed culture that spread its understanding of mathematics, astronomy, and sacred architecture across the world before vanishing from the historical record. This lost civilization, they argue, provided the seed, and what we see in Egypt, the Americas, and China are the independently flourishing branches of that original global tree. The counter-argument is equally compelling. Critics of this grand unified theory point to the natural evolution of architecture. Every society begins with a simple mound. As they grow more complex and wish to build higher and more stable monuments, the mound logically evolves into a stepped platform and then into a true pyramid. It is the path of least resistance in engineering, a convergent evolution of form driven by universal laws of physics and stability. They argue that the human mind, when faced with the same fundamental challenges of building tall, stable, and symbolic structures, will naturally arrive at similar solutions. The differences, they say, are just as telling as the similarities. The Egyptians perfected smooth-sided mountains of cut stone. The Maya built towering stepped temples coated in stucco, and the Chinese erected vast, quiet mounds of packed earth. These distinct methods and aesthetics suggest independent development, not slavish copying from a single source. This debate splits into two main schools of thought. On one side are the diffusionists who believe in cultural exchange. They propose that ancient seafarers, perhaps from a forgotten maritime culture, could have traversed the oceans, carrying the core ideas of pyramid building as they went. This knowledge then took root in different soils, adapting to local materials and beliefs. The absence of shipwrecks or other concrete archaeological evidence for such contact is the theory's greatest weakness, yet its supporters argue that ideas are the most potent and elusive cargo, often leaving no physical trace. On the other side are the independent invention theorists. They highlight the distinct timelines and the unique cultural meanings attached to each pyramid tradition. For them, the pyramid is a testament to the universal creative spirit of humanity, a symbol that emerged independently in separate cradles of civilization as they each reached a similar level of social and spiritual complexity. This debate is about more than just stones. It strikes at the heart of who we are. Does human history tell a story of isolated cultures developing in unique bubbles, or one of deep, ancient connections across vast, seemingly impossible distances? Are we a species of independent geniuses, or have we always been a global network, sharing and shaping our collective knowledge? The silent pyramids hold the answer, and they challenge us to reconsider everything we thought we knew about our shared past. The same forces that have preserved these monuments for millennia now threaten to destroy them. A silent war is being waged on every continent against environmental decay, a battle that reveals a final, sobering parallel in the story of pyramids. In the dry Egyptian air, the greatest enemy is not the wind, but an invisible poison rising from below. Groundwater laden with salts seeps up into the Great Pyramid's limestone base. As the water evaporates, the salt crystallizes inside the stone's pores, expanding with immense force and slowly, inexorably, forcing the ancient blocks to powder from within. It is a decay that works from the inside out, a crumbling that cannot be seen until it is too late. Across the ocean, the Mesoamerican pyramids face a more visible assault. In the humid jungles, tree roots seek out the smallest cracks in the stone, prying apart walls that have stood for 1,000 years. The very air has turned acidic from modern pollution, eating away at the intricate carvings and vibrant stucco facades, dissolving the faces of gods and the records of kings. Meanwhile, in China, the great earthen mounds face a slower but equally devastating fate. The relentless scouring of wind and rain carves deep gullies into their sides, softening their sharp geometric forms back into shapeless hills. Farmers seeking fertile land have sometimes leveled the smaller pyramids entirely, their ancient foundations lost to the plow. The response to these threats has become a global mission. In Egypt, engineers are installing advanced drainage systems and capillary barriers around the Giza plateau, trying to divert the salt-laden groundwater away from the pyramid's foundations. At ancient Maya sites, teams of conservators painstakingly remove invasive vegetation, stone by stone, and apply chemical consolidants to harden the weathered surfaces against acid rain. In China, efforts focus on stabilizing the eroding slopes of the Earth pyramids with protective turf and reinforced terracing, while establishing clear boundaries to prevent further agricultural encroachment. The strategies are remarkably similar because the goal is universal: to control water, to reinforce structure, and to manage the human footprint. The challenge of tourism unites all these sites. The very feet of millions of admirers wear down stone stairways, while the humidity from their breath encourages microbial growth on interior walls. The solution has been a shared shift in management, limiting daily visitor numbers, building protective walkways, and closing fragile inner chambers to the public entirely. This acknowledges a difficult truth that our love for these places can, if left unchecked, be the thing that destroys them. This global crisis has sparked an equally global response. International organizations like UNESCO now facilitate a continuous exchange of knowledge between Egyptian geologists, Mexican restoration architects, and Chinese archaeologists. They share data on non-invasive scanning techniques, compare notes on the most effective protective coatings, and develop unified strategies for monitoring structural integrity. A repair method perfected on the Sun Pyramid in Mexico might inform a new approach for stabilizing a crumbling chamber in Egypt. A drainage solution designed for a Chinese mound could offer insights for protecting a site in Guatemala. This worldwide collaboration recognizes these structures not as the property of one nation, but as the shared inheritance of all humanity. The parallel conservation challenges underscore a profound duality in these ancient wonders. They possess an incredible durability, having survived for thousands of years, yet they remain fundamentally vulnerable to the slow, patient forces of nature and the relentless pressure of our modern world. Protecting them for the next 1,000 years demands a level of international cooperation and shared expertise that is unprecedented. In a strange and beautiful way, this modern network of preservation, with its free flow of ideas and resources across borders, eerily mirrors the very kind of ancient international connection that might have given rise to the pyramids in the first place. These stone giants have become our greatest teachers. Long after their last rituals were performed, pyramids around the world continue to serve a vital purpose, not as tombs for kings, but as classrooms for humanity. They ignite a spark of curiosity that transcends language and culture, drawing millions into the fascinating worlds of archaeology, engineering, and ancient history. Walk into any major museum, and you will likely find a pyramid at the heart of an exhibition. children and adults alike gather around scale models of Giza or interactive screens reconstructing the vibrant stucco facades of a Maya temple. These are not just displays of artifacts, they are immersive journeys. Visitors learn about the physics of ramp systems by trying to move a virtual stone block, or they grasp the concept of celestial alignment by manipulating a digital model of El Castillo to see the serpent of light appear on the equinox. The pyramid becomes a gateway, making abstract concepts of ancient technology and cultural development tangible and thrilling. This educational power extends far beyond museum walls. In schools across the globe, the story of the pyramids is a cornerstone curriculum unit. Students in Cairo, Mexico City, and Beijing all learn about these local wonders, but they are also increasingly learning about each other's. Educational programs now deliberately compare the ramped earth technique of China with the limestone quarrying of Egypt and the stucco artistry of the Maya. This comparative approach does more than just list facts. It trains young minds in critical thinking. Students are asked to ponder the same question that has captivated scholars for centuries. Why did these different cultures develop such similar solutions? They are encouraged to see both the universal human impulses and the beautifully distinct cultural expressions, fostering a deeper appreciation for our shared yet diverse human story. The digital revolution has thrown open the doors to these ancient sites for everyone, everywhere. With a smartphone or a computer, you can now take a virtual walk through the Grand Gallery of the Great Pyramid, or soar over the jungle canopy to see the sprawling city of Tikal from a drone's perspective. These are not mere videos, they are three-dimensional, navigable experiences that allow someone sitting in a living room in Norway to stand virtually on the summit of the Pyramid of the Sun in Mexico. This technology is creating a new form of global connection, a shared digital space where people from all nations can meet to explore and wonder together. In this way, the pyramids are fulfilling their original, ancient function in a stunningly modern context. They were always intended as centers of knowledge, places where priest astronomers tracked the stars and where the secrets of the universe were encoded in stone. Today, they serve that same purpose on a global scale. They connect us not to gods but to each other and to the incredible ingenuity of our ancestors. They remind every student, every virtual visitor, that the drive to build, to reach for the sky, and to leave a mark on the world is a thread that binds all of humanity across the vast expanse of time. Even after centuries of study, the pyramids guard their most profound secrets with a silent, stubborn resolve. The very stones we have measured and mapped still hold unanswered questions that now guide the future of exploration. Perhaps the most practical mystery is also the most baffling: the sheer mechanics of moving and placing multi-ton stone blocks with such impossible precision. While we theorize about ramps and sledges, the exact methods for quarrying, transporting, and lifting these colossal stones remain a subject of fierce debate. How did workers achieve such seamless joints that not even a razor blade can slip between them? Then there is the hidden anatomy of these structures. The recent discovery of a massive void within the Great Pyramid using Muon scanning is a thrilling reminder that we do not yet know the full extent of the chambers and passages concealed within these monuments. Similar mysteries likely lie within the unexcavated earthen pyramids of China and the layered temples of Mesoamerica. Our understanding of their astronomical functions is also incomplete. We can see the alignments, but can we fully comprehend the intent? Were these precise orientations part of a larger, global celestial map that we are only beginning to decode? The path to answers now lies in blending old disciplines with new technologies. the future of pyramid research is unapologetically interdisciplinary. It requires archaeologists to work alongside astronomers, materials scientists, and digital modelers. Imagine creating a perfect digital twin of a pyramid, a virtual model where we can simulate ancient construction techniques, test acoustic properties, and model the flow of electromagnetic energy in real time. This is no longer science fiction. Specific priorities are coming into focus. Comprehensive comparative studies that analyze the quarrying techniques in Egypt alongside the rammed earth methods in China could reveal universal principles of ancient engineering. A deeper, more systematic investigation into the acoustic and energy anomalies reported at sites across the world is essential. Are these curious effects merely coincidental, or are they the faint echoes of a forgotten science? We also need more refined dating methods, techniques that can pin down construction timelines with even greater accuracy, helping us to see if these global projects were truly separate or strangely synchronized. The most promising direction, however, is the slow dismantling of academic silos. The greatest breakthroughs will likely come from international collaborations where researchers studying the pyramids of Giza regularly share data with teams working at Teotihuacan and in the Chinese plains. By comparing notes on everything from mortar composition to structural stresses, we may finally gather the evidence needed to answer the ultimate question. Do these monuments stand as independent triumphs of the human spirit, or are they the scattered proof of ancient, global connections that rewrite our history? This enduring mystery, the tantalizing gap between what we know and what we suspect, is what ensures the pyramids will captivate our imagination for centuries to come. Our journey through these ancient wonders reveals a profound and enduring mystery. From the mathematical precision of the Great Pyramid to the celestial stairways of the Maya and the silent earthen giants of China, we find a tapestry of similarities too consistent to ignore. The same architectural blueprint, detailing precise cardinal alignment, stable slopes, and complex internal chambers, appears across continents separated by vast oceans. This is not merely a story of similar shapes, but of shared design principles that touch upon the very fundamentals of sacred geometry, astronomy, and engineering. Such widespread consistency forces a difficult question upon our conventional understanding of history. How could cultures developing in complete isolation arrive at such identical and complex solutions, from encoding pi in stone to engineering perfect solar calendars? The evidence laid out by these stones challenges the long-held narrative of ancient isolation and purely independent development. It suggests instead a deeper story of human ingenuity, one that may include threads of connection and exchange we are only beginning to recognize. While many questions remain unanswered, and the debate between independent invention and cultural diffusion continues, the pattern itself is undeniable. As new technologies and international collaborations push the boundaries of exploration, we move ever closer to unraveling this ancient puzzle. The pyramids, in their silent, monumental grandeur, stand as a testament not only to the power of individual civilizations but to a shared human drive. They are our collective attempt to bridge earth and sky, to impose cosmic order on our world, and to build something that would echo through the ages, a timeless testament to our enduring quest for meaning.